Start at 0. Make equal jumps. Fractions have places.
Welcome to the Garden Reach. The Wise Math Sheba is here to show us a new way to look at fractions. A fraction is an exact number, and it has a precise physical location on a continuous number line. To find that exact location, we first need to define the whole. On this vine, the whole is the physical distance spanning entirely from the 0 marker to the 1 marker. Placing a fraction on this stretch requires a strict two-step process. First, we cut the whole distance into equal parts. Second, we count those parts starting from 0. Combining these two specific actions, cutting and counting, is how we map a written fraction to a measurable point on the line. Our immediate objective is to accurately locate the fraction 1/4 on the continuous line between 0 and 1. The bottom number, the denominator, tells us how to cut. Because it is 4, we divide the entire vine into 4 identical segments. That first created interval from 0 is our baseline. Fennel, the inchworm, arches across that distance, stopping exactly on the first notch. That specific location is the unit fraction, 1/4. These divisions must be equally spaced. Without equal intervals, the markings won't represent fourths. Using this exact same 4-part line, we can locate a more complex fraction, 3/4. This is where the top number, the numerator, comes into play. Think of this number as active instructions for how many intervals to count from 0. The top number is 3, so we count out 3 intervals. We add a second identical hop to reach 2/4, and a third hop to land squarely on the 3/4 mark. A fraction like 3/4 is simply a composite distance made by stacking multiple identical unit fraction hops together. Let's apply this logic to a completely blank, undivided whole. This time, we need to locate the fraction 2/3. Look closely at the fraction. How many equal cuts do we need to make, and how many counting hops will it take to get there? The bottom number is 3, demanding this new whole be divided into exactly 3 equal sections. The top number is 2, requiring Fennel to make 2 distinct equal hops starting from 0. That second notch is our exact location for 2/3. Even when the physical size of the intervals completely changes, the mechanical process remains consistent. The bottom number dictates the cuts, and the top number dictates the count. Returning to our original vine, look at what occurs when the counting sequence reaches the absolute end of the partitioned line. Fennel takes the 4th and final hop, landing directly on the 1 post. Accumulating 4 hops of 1/4 completely spans the designated distance of the vine. Mathematically, this proves that 4/4 is identical to 1 whole. To place a fraction on the line, use this logic. Cut the whole from 0 to 1 into equal parts to build the unit fraction, then count those parts forward from 0. As we leave the garden reach, try applying that thinking to a fresh problem. If a new vine is cut from 0 to 1 into 6 equal parts, how many hops of 1/6 will it take to locate 4/6? Keep the steps precise, and you will find the exact location every time.
Notches show denominator. Hops show numerator. 4/4 is 1.